Hi everybody, welcome to chapter 9. We're going to start talking about quadratic equations and how to solve them, and the first part of solving them is talking about graphing. So we got a lot of terminology in section 9.1, so I'm actually going to split it into a couple days. The first day is just going to talk about how to graph them and what they are, and then 9.1b is going to talk about actually putting them on a graph. So first of all, quadratic function. Quadratic means that we've got ourselves something like ax squared plus bx plus c, just like what we were doing in the last chapter when we were factoring those trinomials. Notice it's in standard form, descending order for our exponents. Highest exponent first, and then the x term, and then the number. So when we graph these guys, we can graph them. We end up with an equation or a graph that is not linear. In other words, it's not a straight line like y equals mx plus b. We know what y equals mx plus b looks like. We've got ourselves a y-intercept, that's on the y-axis. We've got ourselves a slope. It changes at a constant rate. This is not that. I've already wrote that up at the top. Our standard form for a quadratic function. So standard form, remember, means descending order. Ax to the second power plus something x plus a number. The parent function, the most basic function of this, is y equals x squared, and we're going to talk about that today and what it looks like as far as information, and then graph that in 9.1b. There's actually a name for the shape of a quadratic function. It's called a parabola. And when we make ourselves just a little xy coordinate plane, a parabola looks something like that. And we can flip it over so it opens down instead of up, but that's the shape, like a U type of shape of graph. Notice I've got arrows on either end, and it should be perfectly symmetrical. And we've also got some information from our standard form of our graph. The y-intercept is always the c value. So c value is the y-intercept. It's the point where our graph touches the y-axis. So we're going to talk about a few things. You can see on your note sheet, we're going to talk about the axis of symmetry and the vertex, maxes and mins. There's a lot of stuff in here. So first of all, the axis of symmetry is a vertical line that intersects the parabola. So I'm going to draw myself a little graph again. You could use the same one. Every time we figure out the axis of symmetry, we're going to put that vertical line as a dotted line. And it intersects the parabola. It actually splits it right in half. And it creates a mirror image. So on either side of that dotted line, I should have exact match. You can kind of think of it as a mirror and a reflection over that mirror. The axis of symmetry also contains the vertex. The vertex is that point that is on the axis of symmetry, and it's kind of the middle of the parabola. And last but not least, to find the axis of symmetry, we've got a formula. Remember, we're dealing with our standard form. And just like we identified A's, B's, and C's when we factored what multiplies to A times C but adds to B, we can identify A's, B's, and C's and use those values in our formula, x equals negative B over 2A. If your B is already negative, you're going to make it a positive. If your B is positive, it's going to be a negative because of that formula. Notice it's x equals because it's actually a line. A vertical line is always x equals something. So negative B over 2A. Vertex is kind of the center of the graph. It's also going to be either your highest or your lowest point of your parabola. So I've got my dotted axis of symmetry. So here's my vertex. It lies on the axis of symmetry. And in this case, notice that my vertex is the lowest point of the graph. There isn't anything lower. Notice in this one that I drew over here, just above, that vertex is the highest point of my graph. It doesn't get any higher. These arrows tell us that the graph keeps getting lower and lower. So my vertex, the center, the highest or lowest point of my parabola, it's an actual ordered pair. We're going to find that. It might be -2, 1, or it might be at 0, 3, or it could be at the origin. But it's an actual ordered pair, and you find that ordered pair by using your x value from the axis of symmetry, knowing this formula, -b/2a. You take that value and you plug it in to find y. So you go to your actual equation in standard form and you put that x value in there and you get a y value. So your axis of symmetry is the same as the x value from your vertex. And we're going to go through a couple problems like this so you can actually see. So let's talk about maxes and mins, the highest and lowest value. Notice I've got my ax squared plus bx plus c. A parabola opens upward. That's opening up when the a value is positive. So for example, I might have y equals 2x squared plus 5x plus 7. My a value in this problem is 2. It's a positive 2, so my graph opens up. So my vertex right here is the lowest point of the graph. There's nothing lower. The arrows tell you the graph keeps going up. That's called a minimum. Makes sense, right? Minimum would be the least amount I possibly have. A parabola opens down when my a value is negative. So here's a parabola opening down. For example, I might have y equals -x squared plus x minus 4. I don't know, I'm just making those numbers up. But this is my vertex, the center of my graph. And that vertex is the highest point of the graph. The arrows tell you that the parabola keeps going down, so that's called a maximum. And in the homework or whenever, if I ask you for what is the actual min or max value, you're going to tell me the y value of that vertex. So for this example right here that I just drew in blue, my maximum value looks like it is 1, 2, 3, 4. Max value equals 4. I don't care how far left or right it goes. I want to know what is the actual highest point. It's 4. My min value for this green one is the y value. It looks like it's at 2. 2 is the lowest possible y value that I can get when I do that. All right, so there's a bunch of terminology. You're going to need to know that stuff. But let's analyze. This is how we find all of our stuff if we're actually going to graph them. So the first thing you're going to do is you're going to find the vertex. In order to find the vertex, you have to find the axis of symmetry. That formula, -b/2a, is your x value. Then, to finish the vertex and get the ordered pair, you're going to plug in, you're going to use, I'll put use that, and find y. We'll do an example like this so that you can see. The y-intercept, we mentioned up above, is always equal to the c value in the original equation. If there isn't anything, it's 0. So it's always equal to the c value. After you've got that, when we're actually graphing, we may need to find additional points using an XY table. We need to have at least 3 points, and we can use that symmetry or that mirror image from our axis of symmetry to help us out. But we may need to make an XY table. And step 4 is kind of a helpful extra thing, if possible. If possible, solve the quadratic equation by factoring. Figure out the solutions, and I'll talk in 9.1b about where those go. But if you can factor that guy and set it equal to 0, make each piece equal to 0 and solve, find out what goes in the swirly brackets, you have more points on your graph. That could save you from needing an XY table. All right, so let's do a couple practice problems. Number 1, I've got y equals x squared minus 2x minus 3. Notice that's in standard form. My x squared is first, my number is last. If I wanted to identify a, b, and c, what's my a value from this graph? What's my number in front of, or from this equation? Number in front of the x squared is 1. What's my number in front of my x term? Good eye on the negative. And my c value? So I've got all that information. You don't have to write that, but it's just helpful to see it on the side. So let's start by finding the axis of symmetry. Memorize this equation. X equals negative b over 2a. So what do we do if b is negative 2 and I want to do a negative 2? I would do positive 2 over 2 times 1. Everybody see why that 2 became positive? So what is 2 over 2 times 1? Remember, do the multiplying, finish the fraction. I would say my axis of symmetry is x equals 1. To find my vertex, I know it's going to be 1 something because I'm going to take that value from my axis of symmetry and I'm going to do some math to find the y value. It tells you that x equals 1, so that's what I'm going to use for my vertex. So if I put a 1 into this equation, 1 to the second minus 2 times 1 minus 3. So when I say plug in that 1, I mean actually go to your original equation and do the math. So 1 squared is 1 minus 2 minus 3. What's 1? And some of you are going to go to your calculators and just type the whole thing in. But I want you to see what's happening, and I want to make sure we talk about a negative when we square it. I think we've talked about this 100 times. So 1 minus 2 minus 3, would you agree that's going to be a negative 4 for our vertex? So 1 negative 4 will be the actual ordered pair where we will find that vertex. So does that parabola, look at our original equation, open up or down? Or is the vertex 1 negative 4 a maximum or a minimum point? Well, it looks to me like my a value is positive, positive 1. So that means that my parabola is going to open up, which means my vertex should be a minimum point. Y-intercept, remember, is always your c value. What's my c value? Negative 3. And last but not least, factor or find solutions if possible. I am telling you for these first couple problems, they can be factored. We're going to find out in section 9.2, not everything can be factored. So if you can, this is really useful additional information that will help you to do the graphing, which is the point of this whole section called graphing quadratic equations. So if I want to factor this, I'm going to take my x squared minus 2x minus 3, set it equal to 0, do a square method, do a product sum table, do whatever you need to do, hit pause and do that right now. Don't forget how to factor because that's kind of a big deal. Equals negative 2x, or what multiplies to negative 3 and adds to negative 2. Whatever way works for you. I'm going to hit fast forward. And I'm going to go right to my 2 sets of parentheses. And when I factored that guy, I got an x minus 3 and an x plus 1. So when I set each one equal to 0, inside my solutions, swirly brackets, I'm saying my solutions are negative 1 and positive 3. So set that information on hold for just a second. Actually, when we get to 9.1b, we're going to use this same equation for our first one, and we are going to graph that. We're going to use all this information with these 4 boxes right here, and we're going to put all that information on a graph. We've actually got enough information that we don't need to make an XY table. So example number 2, I wanted to make sure we did one with a y equals negative 2x squared plus 2x plus 4. So first of all, axis of symmetry, do you know, well, how about this? First of all, a, b, and c, right? What's my a value in this equation? B value, positive 2, and c value is 4. You may already know the y-intercept. However, I'm going to start with the axis of symmetry. Please write x equals negative b over 2a every single time. This one might not be quite so nice as the last one. Negative b will be a negative 2 over 2 times negative 2. So negative 2 over negative 4. I'm going to write it as x equals positive 1/2. If you want to do a 0.5, you could. But that's my axis of symmetry. Can you find 1/2 on a graph and make a vertical line through it? Absolutely, right? It's just going to be a guideline for us. So now for my vertex, I'm going to plug in 1/2, and I'm going to do the math to figure out what the rest of my vertex is. I'm going to do this over here, I think. So negative 2 times 1/2 squared plus 2 times 1/2 plus 4. We're still going to get a fraction, but that's all right. I happen to know that 1/2 times 1/2 is 1/4 times negative 2, so that's a negative 1/2 plus 1 plus 4. Double check my math, but I think when I do that math, I ended up with a 4.5 or a 4.5. So my vertex is going to be at over 1/2 up 4.5. It's all right, we can do that, no big deal. My a value tells me whether I've got a max or a min. My graph with a negative 2x squared should open down something like that. So is this vertex value right here a maximum or a minimum? All that max or min tells you is what the graph should look like. What is the actual max value? Max value would be 4.5. Remember, it's the y value. I don't care that I went over 1/2. I only care that I went up 4.5. Y-intercept for this problem is my c value, so y-intercept equals 4. And if I'm going to factor this guy, negative 2x squared plus 2x plus 4. First thing I notice is a GCF. I'm going to make that equal to 0. I'm going to take out a negative with my 2 because I do not like, whoops, that makes that a minus x and a minus 2. I do not like having a negative on the x squared spot. So make your xy table, do your product sum table, make your square to graph or to factor, whatever makes you happiest. Hit pause, do that now, because when I factor that, I end up with an x minus 2 and an x plus 1. Set each one equal to 0. Negative 2 equals 0 really doesn't tell you anything, right? So I'm just going to cross that guy out. If it was x equals 0, it would tell us something. But inside my swirly brackets, I end up with a negative 1 and a positive 2. If it won't factor, if it's prime, then we're just going to have to skip those points. But those negative 1 and 2 are actually points on our graph. So your job, there is no lesson summary and no practice problem, but number 3 is your practice problem. So I want you to find the axis of symmetry, the vertex, whether that vertex is a max or a min, the y-intercept, and factoring might be really tricky because it's really hard to factor x squared equals 0. So I want to make sure that you get that a, b, and c. If there isn't anything like a b, what would you put there? Right? We could say that this is the same as y equals x squared plus 0x plus 0. Factoring's not going to be possible, so you got nothing inside those swirly brackets. Tell me the other stuff, and then we'll start taking this in 9-1B and putting them on a graph. Good night and good luck.